In this video, we're actually going to talk about the quotient rule. So again, it's back on the front page. The quotient rule is almost the same as the product rule, except your answer is going to look like a fraction. And then instead of addition, we're going to have subtraction. So we still can only differentiate one thing at a time. So we read top to bottom. So that's where we start this time. So we take the derivative of the numerator. So I'll put n for numerator. And then we multiply by the denominator. So we kind of just drop him down. Then we subtract. Now we're going to go bottom to top. So now we start at the bottom with g of x, and we take the derivative of the denominator. And then the numerator is the one that would just get carried down. Finally, if it starts as a fraction, it's going to end as a fraction. So we put all of that over top of whatever this denominator is squared. And that's what we're going to practice in this video. So if you go over to example 5, there's actually a typo here in part B, but we'll talk about that in a second. When we take the derivative here, there's no way to rewrite this. So we're going to start with the top and move towards the bottom. So the derivative of y is going to be the derivative of the numerator, which is just 3. And then the denominator is going to carry down. And then we're going to subtract, because this is the quotient rule. Now we're going to go bottom to top. So now we take the derivative of the denominator, which is 2x. And then the numerator is the one that will just kind of carry over. And that's all over the denominator squared. Something like this, you may or may not simplify. It depends on what else you need to do with it. If the directions are to take the derivative, then you are done. This is your derivative. Eventually, we will do more with that. Part B, there's not a typo. This guy actually does not require the quotient rule, and I'll show you that here in a second. So let's go ahead and let's add some things to this. We'll just add an x plus and make that guy a binomial in the bottom so that we have to use the quotient rule. So again, here we must use it. So we're going to start top and work our way to the bottom. Again, this does not match your notes, so go ahead and change your notes to say x plus 8. So we take the derivative of the numerator first, and in this case we'll have 2x minus 4. This must be in parentheses because it's a binomial. And then the denominator will drop down right here, x plus 8. We're going to subtract, and now we're going to work our way bottom to top. So the derivative of the bottom will just be 1. And then the numerator is going to be x squared minus 4x. And that's all going to be over the denominator squared. Okay. Again, this looks pretty ugly. So if we don't have to use these rules, we really try not to. It's really easy to make a little mistake somewhere in the middle of all of this. Plus, if we have to go further with this, these are kind of a little bit ugly to look at. So here I'm going to show you some ways that we can rewrite functions so that the quotient rule is no longer necessary. In the denominator, we have a monomial, and even better, it's just a constant. So what we can actually do is we can think of the numerator as having a 1 in front of it. And now, hopefully you can see that there's really a 1/8 in the front of this. So I can rewrite this as 1/8 times x squared minus 4x. And if you're nervous if that's right or not, you can always put this guy over 1, and then you can multiply and see if we get this guy here, which is what we started with. And we will, okay? So once it's written like this now, it does not require the quotient rule. When we take our derivative, if it's a coefficient that has no variables in it, it just drops down in our answer. And then the derivative of this guy is going to be 2x minus 4. And that looks much better than it would if we were to have used the quotient rule. So we can do the same thing in the next example. Here we see 3/5. So we can really pull that out front and write it as 3/5 times x to the third. And now we can just apply the power rule. So here if I multiply, I'll get 9/5. And it's now going to be x to the second. And finally here, even though we have this guy on the bottom and he is a variable, we still can rewrite it. We can't really pull him out front like we did with this 5 and the 3, because this guy's not a number. But what we can do, hopefully you remember, is subtract exponents. Since those will both have a base of x, if we subtract exponents, we're going to do 5 halves minus 1, and we're going to get 6x to the 3 halves. Technically on the bottom there's a 1 left. Again, we don't really need that 1. And now we can take the derivative without using any special rules. The derivative here, when I bring this out and multiply by 3 halves, I can actually divide first. So I'll get 3 times 3, which is 9. Or you could do 6 times 3, which is 18, and then divide by 2. Same thing. And then 3 halves minus 1 is going to be 1. And then on this last page, it just talks about higher order derivatives. So our original function in a real life example is called our position function, and typically gives us our height. Once we take the first derivative, that gives us the velocity of a function. Velocity is both speed plus direction. If we take the derivative of that, that's now called our second derivative, and that will give us the acceleration of any function. So here's kind of just notation. Really, I've never actually seen any of these in real life. These are super common, these are super common, and these are super common. You may see these, but they're not as common. But if we want to find the second derivative, we just take the derivative again. Once we get past 3, we don't really put 4 tick marks here, we just kind of put a 4 in parentheses. Again, there's one chapter where we may see any of that kind of notation.